The name of this podcast is Amiah McCray's Derivative Methods in Professor Lewis' Calculus 1 class at Clark Atlanta University. A derivative equals the slope, which equals the instantaneous velocity, which equals the instantaneous speed. Slopes and derivatives are related because the derivative of a function at a point is the slope of a tangent or secant line to the curve at the point. Point slope formula can be used when you have derivatives to help find the equation of the line. The point slope formula is y minus y1 equals m, which is the slope, times x minus x1. Now I will begin to tell you some derivative rules that I learned in this course. First, it is the product rule. The product rule, it would be the derivative of f of x times g of x. What helps me remember this function is I say that the first function times the derivative of the second function plus the second function times the derivative of the first. So it would look as if f of x times g prime of x plus g of x times f prime of x. And that's the product rule. The second rule is the constant rule. The constant rule is fairly easy. It says that the derivative of a constant equals 0. So pretty much if I have f of x equals 5, that would equal 0 because 5 will be a constant. Next is the constant multiple rule. It says that the constant multiple rule is when the derivative of a constant multiplied by the function is the constant multiplied by the derivative of the original function. So an example for that is if I have 3x raised to the 5th. So in order for me to find the constant multiple, I would do 3 times the derivative of x to the 5th, which would equal 3 times 5x to the 4th. Then I will multiply the 3 and the 5, and it will give me 15x raised to the 4th. That will be an example of the constant multiple rule. My next rule that I learned is the quotient rule. So pretty much for the quotient rule, you have to have 2 x's, one in the numerator and one in the denominator. So what helps me remember this rule is the low times the derivative of the high minus the high times the derivative of the low. Then you would divide by the low squared. So pretty much it would be g of x times the f prime of x minus f of x times the g prime of x, all divided by the g of x squared. And that's the quotient rule. The next rule I talk about is the power rule. So pretty much an example of the power rule, it would be x raised to the n. So first what I would do is I would take n and multiply it by x. Then I would reduce my power. So it'll be nx then raised to n minus 1. Another example is, say if you have f of x, which is x raised to the 5th. So to find the derivative, you take the power 5, bring it to the front of x, and then reduce the power by 1. So I'll be given 5x raised to the 4th. And that's the power rule. The next rule, which was the last rule we learned, was the chain rule. And the chain rule, which is f of g of x. And the chain rule, it occurs when you have more than just x alone. So it could be like x minus 1, like e. Okay, say if you have e to the x. If you have the chain rule, you'll probably get an example like e to the x minus 1. And it's more than just x, so that's how you know you have a chain rule. So pretty much you would just take the derivative of the outer function with respect to the inner function times the derivative of the inner function with respect to x. And that's how you get the chain rule. And other things that I learned was pretty much the first derivatives and the second derivatives. So the first derivative can be written as f prime of x. And the first derivative pretty much measures the rate of change of a function. And the second derivative, it can be written as f double prime of x. And it measures whether the rate of change is increasing or decreasing. And so there you have it. I went over the quotient rule, the power rule, the chain rule, the product rule, the constant rule, the constant multiple rule, the first derivatives, the second derivatives, and also the point slope formula. And there you have it. That will be all.